Angelique Pagan. My student number is 123000. Today is November 30th, 2003, and this is my presentation for Module 3, or Lab 3, titled Measurements and Uncertainty. The objectives of this lab is to demonstrate the use of a vernier scale and explain different reasons for error when grading scales. We also must demonstrate the use of a spring scale and explain the different uses for that error. And we must determine the density of the mass set as the final act. In this lab, students had to wear gloves and the safety glasses that came in the kit. Our measuring instruments are the caliper and spring scales for 5 newtons and 10 newtons, and the materials are the washer, the wooden block, the mass set, and a calculator to calculate the volume, density, and as such. For the first part of this experiment, the students had to measure with a vernier caliper. The first item that was measured with the vernier caliper is a washer. What I did was I took a washer and I tightened the vernier caliper around it. Once you have that done, you must look at the two scales of a vernier caliper, the vernier scale and the main scale. Once you have the washer tightened, you must look at the vernier scale, which is the smaller scale, and you must look upon it where it reaches 0. From there, you must look up into the main scale, and you will see, and this is the first example, that this 0, right here where I pointed, reaches up to 18 millimeters. Now, 18 millimeters what? To figure that out, you must look into the vernier scale once again, and you must see where one of these in the vernier scale reaches one of these up top, the lines, I mean. And once you deduce which one lines up perfectly, which for me is that one, this one, and this one, that is your whole measurement. So in conclusion, the washer measures 18.55 millimeters. Now, how do you convert it? Well, 1 centimeter equals 10 millimeters. So once you do the conversion, 18.55 millimeters equals 1.855 centimeters. The measurement process stays the same throughout. So the washer's inside diameter is 7.70, and when you convert it, it becomes 0.770 centimeters. You can measure the washer's thickness by pressing the washer vertically instead of horizontally. And that gave me 1.60 millimeters, and if we turn it into centimeters, it equals 0.160 centimeters. The wood block length gave 25 millimeters, and if we convert it, it becomes 2.500 centimeters. Once I grabbed the 50-gram mass, I measured it horizontally, meaning side by side, and it gave me 20 millimeters, so that equals 2 centimeters. I also grabbed it vertically, if you can say, and it also gave me 2 centimeters. Now, I put it into the formula to get the volume, and it gave me 6.283 centimeters. I repeated the same process for the 100-gram mass, and it gave me 2.4 centimeters and in diameter and 2.6 in height. Once I put the values into the volume formula, it gave me 11.76 centimeters cubed, because it's volume. The same process is repeated for the 250-gram mass. The diameter of it gave me 2.8 centimeters, and the height gave me 4.9 centimeters. Once we put the values of the diameter and height into the volume formula, it gave us 30.17 centimeters cubed. Finally, it's repeated with the 500-gram mass, and the diameter gave us 3.7 centimeters, and the height gave us 5.540 centimeters. When it's put into the volume formula, the diameter and height, it equals 59.57 centimeters cubed. Now,
A vernier caliper is very, very useful. As we have seen, it measures thickness, inside and outside diameter, and even height. The least count of this instrument is 0.1 millimeters, and the estimated fraction is 0.025 millimeters. Some difficulties I faced when dealing with the vernier caliper is that it isn't digital, so there's always opportunity for human error. Also, grasping things is also difficult at times. For the second activities, the students must deal with the spring scale. At the bottom of the screen, we can see my spring scale, the 5 Newton spring scale. The least count for the gram scale is 10 grams, and the least count for the Newton scale is 0.1 newtons. Now, the estimated fraction, or the uncertainty, for the gram scale is 5 grams, and the Newton scale uncertainty is 0.05 newtons. My 10 Newton scale, as can be seen at the bottom, and its gram scale's least count is 20 grams, and the least count for the Newton scale is 0.2 newtons. The estimated fraction, or the uncertainty, is 10 grams for the gram scale and 0.1 newtons for the Newton scale. Here we can see all my data collected. We can see that the 500 grams stayed consistent throughout. All the measurements stayed consistent throughout. The only thing that changes is the uncertainty. Here we have some photos of my spring scales. If we can see here, this one is measuring the 100 grams weight. Then this one should be measuring the 50 gram weight. And then this one, we should be seeing a 500 right here, meaning the 500 grams weight. Now, what dimensions can be measured with a spring scale? A spring scale can measure the amount of grams and newtons pertaining to an object. Like I said while comparing my measurements in the last slide, the measurements did not change, just the uncertainties. So I say it is more beneficial to use a 5 Newton scale rather than a 10 Newton scale when it is a small object and you'd like your measurement to be more precise. While using the 10 Newton spring scale, it is best used for larger objects, in my opinion, for quick readings but less precise, as we've seen in the uncertainty levels. Now, talking about uncertainty, some forms of uncertainties or sources of uncertainty can stem from the instrument not being calibrated. This off the bat doesn't allow you to get the right measurements, because if the instrument isn't calibrated, your measurement will ultimately always be wrong. Now, to measure the experimental density, one must take the mass and divide by the volume. So 50 grams divided by 6.283 centimeters equals to 7.958. Now, this is repeated throughout this presentation, and that gives us the experimental density for the 50 gram cylinder, the 100 gram cylinder, the 250 gram cylinder, and the 500 gram cylinder. Now, comparing both densities, we can see that the most accurate is this one, the 50 gram cylinder, which gave us a percent error of 2.03%, which is low. It is accepted, we should say. Then we have the 100 gram cylinder, which got a percent error of 9. And then the 250 gram cylinder, which got a percent error of 6, which is our second lowest percent error. And then we have the 500 gram cylinder, which gave us 7.60% error. The ones with most accuracy are between 0 and 5%, and the ones with low accuracy are 5 up until 15. If a person gets a 16% error or above, one must repeat. Now that I have measured and given you my experimental densities and my percent error, we can conclude that my measurements were highly accurate or moderately accurate, which gives a satisfactory completion of this lab. Thank you for listening, and I wish you well.